Our energy supply systems, as we know them today, are changing. Global climate change and the depletion of fossil resources are the main drivers behind the transition towards cleaner, renewable, and less carbon-intensive energy sources. At the same time, energy production is becoming much more decentralized. We are shifting from large-scale power plants to small, decentralized, renewable power production units such as wind, solar, or biomass-driven cogeneration units. In addition to numerous advantages, this change also brings new challenges. Maintaining our high level of supply security with fluctuating, small-scale, renewable energy systems requires new control strategies and technical solutions. Innovative approaches need to be found to better integrate the demand for independent production from wind and solar into the energy grid and market. Better forecasting of volatile renewable energy production is becoming more and more important. Researchers at the Luxembourg Institute of Science and Technology, LIST, are looking into different aspects of this smart green vision.
In a common project of LIST and the Enovos Foundation, which is a non-profit foundation of the local energy provider, we are developing a new approach to forecast the power to be expected from photovoltaic systems in a certain region. We are targeting the short-term horizon of a few hours up to 3 days.
Solar irradiance forecasts from a numerical weather production model are the basis of the forecasting model. With detailed information on the installed power and location of photovoltaic systems and statistical information on their inclination and orientation, the forecast algorithm can calculate a first preview of the solar power that can be expected. The innovative aspect of this approach is its combination with near real-time measured PV power of well-known reference systems. This allows for the adaptation of the forecast on the short-term forecast horizon and aims to increase the forecasting accuracy.
First results have already shown that based on numerical weather predictions only, we are reaching high accuracies for PV power forecasts with clear sky conditions, meaning sunny days. Whereas on cloudy days, the accuracy of the forecasts significantly drops. This is exactly where we believe our combined approach using real-time measurements can help to compensate temporal inaccuracies in the irradiance forecasts.
Improved power forecasts for renewable power production are already a huge step forward in the integration of renewables. But there are further limitations which need to be taken into account when larger shares of our power production are shifted into the voltage distribution grids and when electricity is fed into the grids independent of the current demand. Keeping the voltage within the distribution grid at all its connection points within given limits is one of those important aspects. Without energy production within the distribution grid, the voltage drops gradually along the distribution grid feeders starting at the transformer. Distributed energy producers, as for example PV installations, raise the voltage at their point of injection. If the number of distributed producers rises, the grid reaches the allowed voltage limits in times of high production and low consumption. The hosting capacity of the grid can be increased by technical grid integration measures such as decentralized storage.
We are investigating these measures through simulation and modeling and are applying the models to the case study of the city Esch-sur-Alzette. Through this project setup, we can pursue on one hand an interesting research question, while at the same time developing an energy vision for the city and its energy provider.
Such integrated dynamic modeling of energy production, consumption and transport, and in the future also incorporating market dynamics, is crucial to evaluate the true potential of renewable energy generation. In the future, LIST will therefore focus on the synergies of combining integrated dynamic modeling of energy systems with the life cycle assessment schemes. This interdisciplinary endeavor should assure the sustainability of our smart green vision for the future energy supply.